In this video, we are going to look at real-world problems on arithmetic progressions. These are life situations that require the application of arithmetic progression. So, let's begin. We have a question here. A factory produced 1,100 cars in the 8th year, 2,700 in the 11th year. Assuming production increases by a fixed number every year, find the production of cars in the 20th year and the sum and the total cars produced in the first 20 years. So now we know that. Let's take note of the data given to us. In the 3rd year, which is U3, we have 1,100 cars, and in the 11th year, 2,700 cars. And what else do we know? Fine. Okay, assuming production increases by a fixed number every year. Fixed number would tell us the common difference between the number of cars produced every year. And now we have the 20th, which is not known. So solving for A, we are going to have A equals to 1,100 minus 400. And if we work that, we are going to have A to be 700. Okay, so we need to box this information is also vital, right? Now we have found for the common difference D. We've also found the number of cars produced in the first year, which is 700. So let's go ahead and find the number of cars produced in the 20th year. So this is going to give us U20, which will be given by the expression A plus 19D. So this is going to give us U20 equals to A is 700 plus 19 times the common difference, which is 200, right? So this will be U20 equals to 700 plus, if we check 19 times the common difference, which is 200, we are going to have 3,800. So this will be 3,800. So it means that the number of cars produced in the 20th years is going to be 4,500. So this will be 4,500, right? So let's also box this information is vital. Okay. Now moving on, the next thing we have to find is the total number of cars produced in the first 20th year. And we know that for the sum sequence, the sum of AP has been given to be S of n equals to n divided by 2 times 2 of the first term plus n minus 1 times the common difference. So this expression will help us to find the total number of cars produced in their first 20 years. Okay, so now we are going to look at S of 20, and this will be 20 divided by 2 times 2 of the first term, which is 700, plus 20 minus 1 times 200. Okay, right? So this is going to give us 20. This is going to be divided by 2, so that will give us 10. And let's work in what is inside the bracket. So if we have the what is inside the bracket will give us 2 times 700, which is 1,400. 1,400 plus 20 minus 1 is 19 times 200. Okay, so the sum of the 2010 will give us 10 into bracket 1400, and 19 times 200 will give us 3800. So this will be 1400 plus 3800. Okay, and when you sum what is inside the bracket, we are going to have this to be 1400 plus 3800 will give us 5200. So this will be 5200, and if you multiply this by 10, so this is going to give us 52,000. So in general, we can say that in their first 20th year, this company were able to produce 52,000 cars. Let's move on to the next section. Now, Jane takes up a salary. This will be question number 2. Take up a job of 8,000 per month with annual increment of $100. What will she earn over a period of 10 years? Okay, so we have a friend here, Jane, that took up a job for $8,000 per month, right? So it means that the first 10 year, A will be $8,000 per month, and the common difference D is $100. What will she earn over a period of 10 years? So we know that U10 we don't know. Okay, so and the number n is equals to 10. So means this should be is the sum of the amount n in 10 years. So we know that the sum of arithmetic progression has been given by the formula Sn equals to n divided by 2, and this will be 2 times the first term plus n minus 1 times the common difference. Okay, so let's go ahead and substitute this expression into the information given into this expression. So this will be S10 equals to 10 divided by 2, and this will be 2 times the common difference is 8,000 plus n minus 1, which is 10 minus 1, times the common difference, which is 100. Okay, so it means that this 10 will be equals to, this will be 5 out here. Okay, so 8 times 2 will give us 16,000. So this will be 16,000 plus 9 times 100. Okay, so moving on, this is gonna give us this S10 equals to 5 out there, 16,000 plus 900. No, this is 1,900 because no, it's 9. Sorry. Okay, so this is 10 minus 1 is 9, and 9 times 100 will be 900. Okay, will give us 16,900. So this will be S of 10 equals to 16,900, right? And if you multiply this by 5, you are going to get 84,000. So this is this in 10 years will be 84,500, right? So it means that at the end of 10 years, Jane's salary will sum up to 84,500. Okay, So maybe we could see that this will be $84,500. Okay, so let's take a look at another question. In a flower bed, there are 31 rose plants in the first row, 28 in the second, 25 in the third, and so on. There are 7 rose plants in the last row. How many rows are there in the flower bed? Now, we know that the AP given to us here, so this is going to be the AP. Say that the arithmetic progressions is 31, 28, 25, and it goes on to the last thing, which is what? 7. Okay, so from here we know that the first term A is 31, and the common difference D should be given by the second term minus the first term, which is also equals to the third term minus the second term. So let's go ahead and see if this will be true. We have here 28 minus 31 should also be equals to 25 minus 28. And when you take 28 minus 31 will give us minus 3, and 25 minus 28 is also minus 3. So therefore we can say that the common difference D is minus 3. All right, okay, so we know the first term, and now we also know the common difference. What are we to find? How many roses are there in the flower bed? Okay, so we are going to find the number of roses. If you can say that, let the number of row be, let the number of row be what? N. So let's let n be equals to the number of row. Now we know that un is also equals to the last term equals to the expression a plus n minus 1 times the common difference, right? So it means that the last term has been given, right? So the last term is given to be 7. So it means that we are going to have here to be 7 equals to A is 31 plus n minus 1 times the common difference, which is minus 3. Okay, so this will be 7 equals to 31. When we expand this bracket, we are going to have minus 3n plus 3. Okay, so here will be 7 equals to 31 plus 3 will give us 34. So this will be 34 minus 3n. Grouping like terms, we are going to have 7 minus 34 equals to minus 3n. And when you say 7 minus 34, we are going to have minus 27. So this will be minus 27 equals to minus 3n. And dividing both sides by minus 3, therefore n will be equals to positive 9. So in conclusion, we can say that there are 9 rows in the flower bed. The last question for this section. The houses on Lupe Street are made in such a way that they all lie in one row. The houses are numbered consecutively from 1 to 49. Joe has a house on the same street. His house is situated such that the sum of the numbers of the houses, in fact, let's take note of this information. The sum of the numbers of the houses preceding his house is equals to the sum of the houses follow it. So what is Joe's house? So that's what we are to Fine. Now, let's take note of the information given to us. So we see that this question is an arithmetic progression with the term given to be 1, 2, 3, and it goes on to 49. We also see that A, which is the first term, is 1, and the common difference D is also 1. Okay, now let's let X equals to the number of Joe's house. So this will be number of Joe's house. So that will be the value of X. Now, in arithmetic progression, we know that the sum of the terms, the series, is going to give us n divided by, is given by the expression n divided by 2 times 2 of the first term plus n minus 1 times d, the common difference. Okay, so we have here, this will be x minus 1 should be equals to s of 49 minus s of x. Now let me explain. The x minus 1, we are looking at the partial sum of the houses preceding Joe's house minus the next house. And if you look at the s of 49, it's telling us the partial sum of the houses after Joe's house, okay, or the total sum of the houses after Joe's house. And here we are going to have sx, which tells us the partial sum of all the houses before Joe's house, or as the question said, preceding Joe's house. Okay, so now we are going to work with this expression. Substitute all this into the given expression, right? So it means that we are going to have here to be x minus 1 divided by 2 times 2, the common difference is 1, sorry, the first term is 1, and this will be x minus 1 times the common difference, which is 1, equals to 49 divided by 2 times the first term here is 1 plus 49 minus 1 times the common difference 1 minus x over 2 times 2 of the first term 1 plus x minus 1 times common difference 1. Okay, right? So let's go ahead and simplify what is inside this bracket. So the next thing we are going to have is x minus 1 divided by 2. So if you look at this bracket here, we have here to be 2 plus x minus 1 minus 1. Any number multiplied by 1 remain the same, so we are going to have minus 2. So this and this is gone. So basically what is left in this box is that we just have x, right, equals to. Now when we also look at this bracket here, this is going to be 2 plus 48, right? 48, because 9 minus 1 is going to give us 48. So what we are left in this expression is 49 divided by 2 times 50. 48 plus 2 will give us 50 minus, look at this here, we are going to have 2 plus x minus 1. So what we are left there is x divided by 2 times x plus 1. 2 minus 1 is 1, so we are going to have x plus 1 as that expression. Okay, now by observation, let's see if we can eliminate something. And we have here x minus 1 all divided by 2 times x equals to minus into bracket x divided by 2 times x plus 1. Okay, now if we simplify this, we are going to have x squared minus s squared minus x divided by 2. Maybe I should bring everything to this side and send it to 0. And so this will be s squared plus x divided by 2. This equals to 0. Now when you simplify this is 2. This is s squared plus s squared will give us 2 because the denominator are the same. So we go ahead and simplify the numerator. So this is going to give us 2s squared, and minus s plus x is gone. So all this is being divided by 2. So we are left with 1s squared, right? So it means that in general we are left with the expression here, s squared equals to 50 divided by 2 will give us 25. So this will be 49 times 25. Okay, 49 times 25, and so this will be s squared equals to 1225. And solving for x, s is going to be equals to the square root of 1225. And if you take the square root of 1225, s will give you 35. So we can say that the Joe house is number 35. So the question is, what is Joe's house number? So we can say that Joe's house number is 35. Okay, so we can locate him at number 35.